So this is the Waves Homework Booklet question 30. So we've got this diagram below showing paths of microwaves from two narrow slits acting as coherent sources. So there are the two slits, there and there, through a vacuum to the detector. Obviously we'll be getting waves going out in all directions from those slits, but we're just concentrating on the two directions that head off to the detector. Explain what is meant by coherent sources. That's simply sources that are giving out waves with the same frequency and a constant phase difference. It's not enough to say that they're in phase, we have to say that there's a constant phase difference between them. Frequency of the microwaves is 9.4 gigahertz. Calculate the wavelength of the waves. Very straightforward C equals F lambda calculation. So lambda is C upon F. Speed of light divided by the frequency we're given. Gigahertz is 10 to the 9, so we've got 9.4 times 10 to the 9. That gives a wavelength of 0.032 meters. Moving on then, use the diagram above and your answer to part B1. Calculate the path difference between the two waves arriving at the detector. So if we go back to the diagram, what we're being asked is how much longer is that path compared with that path? Well, this one is 1, 2, 3, lost count, 1, 2, 3, 4, 5, 6 wavelengths. That one's 1, 2, 3, 4, 5 wavelengths. So the path difference between that at 6 wavelengths, that at 5 wavelengths, is 1 wavelength. But they're after a path difference in meters, so we need to multiply up that path difference in wavelengths by the length of each meter, 0.032 meters, the same as the wavelength that we found in the previous part. So it's the wavelength multiplied by 6 take 5. State and explain whether or not we're going to get a maximum or a minimum at that position shown. It's going to be a maximum because we've got constructive interference, because the path difference is n lambda, and so the waves meet in phase. So really I'd probably answer it by starting here. There will be constructive interference because the path difference is n lambda. No, let me try that again. I'll start here. Because the path difference is a whole number of wavelengths times lambda, the waves will meet in phase. That means there's going to be constructive interference, and so a maximum. And then we've got that rearranged so that the perpendicular distance from slits to detector is 0.42 meters, and the interference fringe spacing changes to 0.11 meters, and you're asked to calculate the slit separation. So that's just using lambda as SW upon D. Lambda, the wavelength, is the slit separation times W, the fringe separation, divided by D. Rearrange that to find the slit separation S is lambda D upon W. Lambda 0.32 times D 0.42 divided by the fringe separation that we're given 0.11. That gives me a slit separation of 0.12 meters. That needs to be to two significant figures. All the data there is to two significant figures. And then finally, the detector at that maximum position, the frequency of the microwaves is doubled, and you're asked to state and explain what would now be detected by the detector at the same position. So if we double the frequency, we're going to halve the wavelength, C equals F lambda. So that same distance, that same path difference of 0.032 meters will still be a whole number of wavelengths. Previously it was 1 wavelength, now it'll be 2 wavelengths, but we've got a path difference of a whole number of wavelengths. It's now going to be 2n wavelengths. Where n in this case in fact was 1, so it's going to be 2 wavelengths. And if it's exactly 2 wavelengths, again, the waves are going to meet in phase, we're going to have constructive interference, we're going to have a maximum. So that's Waves Homework Booklet question 30.